Is my voice is audible, sir?
हाँ हाँ ऑडिबल है.
So my name is Ramkesh Misra, and I enrolled in 2018 for my PhD program. I am supervised by Dr. Siddharth Urologin and co-supervised by Dr. J. Angela Jyoti. Today, my thesis title is Design and Development of Tourism Expert System using Machine Learning Techniques. Topic which I am going to cover today is the introduction, importance of tourism sector, integration of the technology with the tourism, motivation, challenges, then the literature survey, and what are the research gap been found through literature survey, then objective and methodology. And the first objective is the tourist forecasting system, which will be discussed through dataset, methodology, and experimental result. Then fourth is the next objective, like tourist recommended system, which will be covered through the TF IDF and PUI recommended system. Then fifth one is the third objective, which is a tourist social media analysis, classification, and topic modeling, which will have the two parts. One is the sentiment analysis and the topic modeling. Second is the knowledge-based topic retrieval. Sixth is a cluster-based knowledge graph and entity relationship representation. And here also I'm going to discuss about what are the methods have been used and then experimental result. Then the last tourist facial expression prediction and application, and for that used methods, experimental result, at the end conclusion and future scope. So as we know that the tourism is playing a major role for the economical expansion for the many countries, and as we can see that it is one of the economical pillars for the development of the many dimensions. And this is a report which is showing that the uh, that every year the international tourist arrival is keep on increasing with the exponential growth, and the amount what is receiving through the travelers, that is also a huge amounts. So from year 2000s to 2021 reports by even United Nations World Tourism Organizations, it is quite it can be seen that in the 2015 there were the 1,206 millions travelers, and through that around thousands billions revenues has been generated. But due to the downfall by COVID-19, it's got reduced, but still it is one of the topmost contribution in the contributor in the economy. Why this sector is very much important? Because the 10.3% of the global GDP, which is equivalent to the 9.6 trillion, and 1 out of 10 job is given by this domain. And many of the this tourism businesses is quite equal to the oil export, food product, and automobile industries. So why technology is playing an important role in tourism? As per the survey given by World Travel Technology Market, that there is a 9% of the growth which has been observed from 2010 to 2023, where the this tourism domain has used the software applications to improve the services. But if in the recent time, the infusion of the AI and machine learning is playing a major role to improve the services. Few of the role is like the recommendation of the product, individualizing the pricing as per the user interest. The motivations behind selecting this domain is to interconnections between other subdomain like transport, government, healthcare, agent, tourist. Then still still the technology has not yet enabled in the full extent, and simple reason is that the information is very scattered. There is no centralized locations where the tourists can find, and they will able to make a decisions to make a travel plans. So if we are going to use the AI and machine learning techniques for the few of the things like recommendation and forecasting, even analyzing the social media data, this may improve the tourism services. Major challenges in this domain is the rare availability of the data, and even the many of the top organizations like booking.com, trip advisors, they don't want to share data for the research purpose. Even I tried contacting them, but the response was no. And most of the research is more into the theoretical side due to the more researchers from the management domain. They are doing research, building the theoretical model, but still the limited practical implementations are there. Then if I'll talk about the major challenges as for the administrative agency point of view. The government agencies faces problem like pre-planning due to the unorganized of the data, so they cannot make a proper planning that what are the services need to be improved for the tourists. So this is a literacy survey. As we can see that that authors in the 13th they use the time series analysis um, are using the ARIMA models to build the forecasting model. Then seasonal ARIMA model along with the guards algorithms have been used as to build the forecasting model to observe the tourist arrival in Taiwan. Even in the next, authors have used the seasonal ARIMA to predict the demand of traveling by airs, and which has the better predictions rate than the other models. But what a major research gap through this domain is that these are the traditional statistical approaches where I know these models deal with the smaller scale of data. But if we wanted to deal with the multi-variety of data, I mean from small scale to the larger scale, MLDL techniques may improve the forecasting accuracy in the larger aspects. And second major gap is that still the we need to build such a system where the most of the data should be in the centralized location, and it should able to cover each and every granular level of information like weekly, monthly, and early. Literacy survey for the recommended system, like yes, Zheng applied the supervised technique along with the lambda mart on the historical sequence data to build the recommended system. Even the novel personalized travel recommended system has been suggested by SGen by removing the inequality of the collaborative filtering along with the content-based filtering. Even M. Nilasi has applied the cluster ensemble techniques for the better predictive accuracy as compared to the single cluster technique. But many of the information is shared by the travelers, yeah, tourism related stakeholders like the name, age, email, etc. And these are the information which can be used to recommend the personalized based product, I mean the personalized pricing, etc. So there is a area where it is lacking. And the second is the hybrid approaches may minimize the user effort. So this is a one where we need to work more into the deeply. Third is the sentiment classification and topping modeling. Many of the researchers working to build the sentiment classifier model. For example, Christian Zwecker has proposed a review system for the hotel by applying the opinion mining technique. Even C.A. Martins, he used to use and develop the classifier to determine the sentiment of the review collected from the several hotel platform. But still we need more accurate classifier where the accuracies can be improved in the better way, and it should able to deal with the different sources of data like blog data, social media data, and multimedia other multimedia data. Literacy for the cluster-based knowledge graph and entity relationship extractions. Few of the top companies like Google and Microsoft, they are heavily investing on building the knowledge graph so that they should able to to summarize the information into the graphical format. But this is the quite ongoing recent areas where a lot of research need to be done. A lot of gaps are there. So our focus is more into the tourism side, that how we can utilize the social media data to summarize the information and visualize to discover entity relationship relationship. Facial expression, uh, people are researchers are developing the facial expression classification model. And in the reference number 126 we can see that feature based and image based techniques have been applied to classify and detect the facial images. Even in the 133 techniques, face detections and leaf feature extractions are described, and they use an AV based classifier to detect the faces. But these are the individual models where they are doing good, but still the accuracy can be increased by combining more than 2 or 3 models, which is called basically deep hybrid approaches. So major research gap where found through this literature is to we need to work on more accurate model which should able to identify the different nationalities faces if a traveler is visiting in any place. Based on the research gap, the major objective what I decided is to develop a tourist expert system using machine learning technique. The sub goal of the system is follow the development of tourist forecasting system, which will able to forecast the number of visitors and what time the tourists will visit and how much time the tourists will stay in a particular place, and building the recommended system by utilizing the review rating and location based information, then analyzing and building the sentiment classification and topic modeling system based on the social media informations, then organizing and representing the high density of information in the form of knowledge graph by extracting entity and relationship, then utilizing the tourist facial images to develop accurate hybrid based facial expression and classifications model. So this is the overall structures. Tourist related information or tourism related data is available in the different form like time series, review rating, location, social media data, and facial expression. So time series data is being used for the building the tourist forecasting system. Review and location is being used for the tourist recommended system. Then social media data is being used for the sentiment analysis and classification along with the knowledge graph. Then facial expression data is being used for facial expression classification and prediction. So now the first objective is to development of tourist forecasting system. So this is the overall structure that firstly we collected the worldwide tourist arrival data and the data has been analyzed as for the year wise, country wise, continent wise, and sub region wise, and then it has gone to the different pre-processing technique before sending to the machine learning model building. Then pre-processed data has been used to develop the forecasting system and which is used for forecasting result. So data set what has been used here is that we use the uh, self-collected data from the different countries, and we will able to see that Asia having the 48 countries and Africa having the 54 countries. These are the top 10 tourist arrival countries. United States having the number one arrivals, then Spain, then Mexico, and that's how the these around 200 countries data have been collected to build the forecasting system. This is the regressions plot where we are just analyzing that how the data is distributed. So we are able to say that see that here for the United States there is a large number of arrivals. So here the data point is quite separate here, but most of the data point is fitting to the regressions line, and it is showing that data is more linear. It is not much scattered. So in such case we yeah, so after this analysis we found that we need to pre-process the data and make into the suitable format of forecasting system. So for processing the data we use the self-lag differencing method, and for the 3 years of data which has been used for the training and fourth year for the forecasting. So in this table we will able to see that this is sample collected data for the top 10 countries. Then this is a pre-processed data in table 3.2 which is showing that if we'll see the 2013 data, so 10 11 12 data will go for the training and 13 data will go for the predictions part. Then machine learning technique have been used, basically two methods which I explored. Since the data is more linear, so regressions techniques have been applied. So support vector regression and random forest regressions is being used for this experimental study. So support vector regression is quite similar to the support vector machine. If we are dealing with the numerical real numbers data, this support vector machine changes its variant to the regressions, and we will able to see here that this is the hyperplane, and if any data points which are available to the space, and it can be measured through some potential sub vectors, I mean the epsilon, which says that how much far a data point is with the hyperplane. So that's how to minimize the error that this epsilon is used here. So formula for the support vector regression is fx is equal to wt phi x plus p. So phi w is the weight vector for the L dimensions. Phi x is the functions that max x fixes to the space with L dimension. B is the bias, and epsilon is the distance between hyperplane and two boundary lines. But if we wanted to minimize the error rate between the data points, then this is the formula. 3.2 is going to help us. The min of 1 by 2 and weight square. Then second part is random forest regression. This is complete tree structure data arrangements where we have the left and right subtree, and data nodes will be organized as per Gini index formula, and then whether the data is going to the accurate tree or not, that part is taken care by the residual sum of square. And for that, we found that support vector regressions with the kernel, a linear kernel, is performing better, which is 0.9% accuracy, I mean the 99% accuracy. Then if we are using the kernel with the RVF techniques, then 86% accuracy is coming, and the RFAR with the tree model which is being used, which is giving the 84 percent accuracy. One of the more study which has been performed through this analysis, that how the forecasting model is changing its variant if the COVID is there. So without COVID, if we are not including the COVID data, I mean the due to the lockdown enforcement, the meant the arrival was very limited. So this figure one is shows that forecasting arrival is quite normal. It is growing into the next level, I mean the arrival is increasing. But wherever uh, including the COVID, I mean 2020 years data, then suddenly it's fall down, and upper bound is reviving after the 4 year. I mean that it has projected that by 2023 or 2024 it will come to the normalcy. Now the objective two, the development of tourist recommended system. So first approach here, uh, we applied the TF-IDF approach for the hotel recommender system, and here dataset what is being used, that is the 515 hotel review data, which is basically the number of hotels which are available in the Europe. Then the different kind of pre-processed techniques have been applied, like making a proper format data, tokenizing the reviews, and removing the stop but etc. And for this, the features what going to be used, the average score, hotel name, negative review, positive review, and review date. So TF-IDF is one of the approach. This is quite popular techniques which follows the lexicon approach. So TF is represented by the number of times the T appears in a documents divided by total number of terms in a documents. Then IDF is represented by total number of documents divided by number of documents with word T. Then by multiplying both values, TF multiply IDF, this will give the TF-IDF scores. So this is one which will give the review scores if we are calculating each and every terms. Then if we wanted to find the similar kind of hotels, for that that using the cosine similarities formula, and which is given by the dot product of xi and yi divided by xi square, root of xi square, and root of by I square. Based on that, we found that the result, these are the top 10 hotels, like Ritz Paris having the 9.72 scores, even for Hotel Casa, compare 9.7. Then H10 Casa Million like 9.6. So these are the top 10 hotels with the review scores. Then the TF-IDF, how it is assigning each and every term to the weight value, this is given in this table, and we are able to see that the terms which is stored in the index number 70,675 having the weight value of 0.0125. And for the getting the similar recommended hotel, if let's say we are giving input hotel as a hotel pooltizer, so the similar kind of hotels will shown to the users that these are the quite similar rating hotels which are listed in the table. Second technique is the recommendation of the POI using sentiment analysis. So for that, that the data source what is being used, that is from the tourpedia.org, And this data, this website basically provide the data for accommodation, restaurants, POI and attraction. Data has been extracted by using different kind of baby scraping technique from the basically four social media platform like Facebook, Foursquare, Google Places, and Booking.com. And the shape of the data is for these eight cities like Amsterdam, Berlin, Barcelona, Dubai, London, Paris, Rome, and Tuscany. So this is a overall shape for PUI only. I'm not going to use here the accommodation, restaurant, and attraction. This is only the PUI data which is being used for this research. Then the data will get through different kind of pre-processing technique like tokenizing, feature extraction, then calculating the sentiments using the sentiment intensity calculation method, then getting the ranking of sentiments value, then recommending the hotels. So before building the model, data has to be cleaned, um, but when we analyze the data, we found that many of the record ID does not have the review parts. Since our major focus was to deeply observing the review along with the numerical rating, so we removed those parts where the review was not available. So after the cleaning of those data, the real shape of the cities is, let's say, for the Berlin, now the 5,000 records along with the 12 features data. Then pre-processing, removal of the stop words, so that we will able to build the model in more faster and efficient way. So most of the number of occurrence like these appearing more than 12,000 times in the text corpus. So these kind of words has been removed from the data source. This is the analysis part, that most of the rating belong to the 5, and then 0 is also there, then 10 is there, and then this is a rating distributions of the data, and this is a month wise month, the number of reviews received, received for the particular places. And then this is a different kind of languages which are available. This is just the analysis part before moving ahead for the next part. So for the experimental study, we use the Python analytical libraries, and the sentiment intensity analyzers basically give the values between -1 to 1. And uh, this uh, chart, we will able to see here in the plot that most of the sentiments is towards the 0 only, because this which is called basically the neutral. Then one side is this, I mean the intensity of the red points represent that what is the basically the rating of particular places. So this is basically the actual result. So total sentiments sum of, and polarity sum, these are the total sum. Then mean value has been basically used to find the ranking. So this is a mean sentiments value and mean polarity value for each and every places. So basically based on these ranked by combining both part, uh, the top places has been recommended. This is the top 10 places which is basically being used to recommend to the users. So in this research, we try to find the favorite places based on the reviews given by the visitors. The next same part has been extended to the by utilizing the reinforcement learning. Here, any users who is quite ambiguous and not finding the suitable places, and so the this recommended system have the list of point of interest places, and which have the review data along with the numerical rating. And then this review sentiments value is also being utilized, and then we are giving the equally importance to the numerical rating as well. Both rating is being merged here, and then these merged value will be normalized into the uh, uh, to the single range like between 0 to 1. Then along with that, latitude longitude also is being used to fitting to the reinforcement learning model. Basically the basic idea behind this is that how well and top rated places a user can find using this algorithms. So the reinforcement learning works based on the penalty and rewards. So if the place is very far, then the agent will penalize those no high long distance places a bit more, but any place which is near but having good rating, I mean the rating which is achieved here, I mean the numerical rating and sentiments value, then places will get more rewards for that. So based on that, a queue table will be prepared by the reinforcement learning, which will recommend it to the users. So this is sentiment calculations. Wider is being used to calculate the emotions of the reviews. Then the wider formula can be represented by x is equal to x divided by x square plus alpha, where the alpha is the normalization factor, which basically used to balance the score. Then this is the sentiment score for these top 10 places. Then this is a numerical rating. Both has been merged and given the new rating. And this rating has been used in the different form also. One more techniques which is being used here to providing the new novel rating for the places. So 5-star rating has been proposed, um, basically which helps that, which is basically the combination of review and numerical rating. Then then PY recommendation is working by utilizing this latitude and longitude. So how this reinforcement learning is working here? So we have the agent, then we are evaluating the agent by running it to the number of episode. For example, if we are training an agent for the 30,000 episode for each and every cities, so that number of episode will run using this formula. We have the current stage of the Q table, then old stage, then alpha, basically alpha represent the learning rate, then there is a decay rate, which is basically used to balance the uh, control the agents, how much the future rewards will play a major role to provide the rating. So this is a basically formula which helps us to train the agents. This is a hyperparameter tuning with different kind of terms which are being used, like epsilon, decay rate, alpha. This is a learning rate, as I already discussed in the formula. Based on that, um, this is the average score rating and distance with the changes in the number of UI bit state. So if a number of episode is 8, I mean if the number of places a user is exploring 8, so number of UI per episode will be 50. I mean this is a random. Initially, the agent will initialize from the random numbers, which will go till 50, and that's how the we are using the this is a basically distance score. If the distance is very high, then accordingly the agent is giving the penalty in the minus. This is a overall score, number of UI visited versus overall scores, and the number of UI visited average rating of UIs. That's how the average rating is going around 20 for the particular. I mean the 4.8 is the average rating. A number of UI a user is visiting is 20. This is basically the ideal range. So this is overall score versus rating multiplier, how the agent is multiplying the different places, and the kind of results what is available here. Then overall score with the distance multiplier along with the rewards point. And based on that, if we are trying to find a place, let's say we consider a city Tuscany, and from here the user wanted to start the number, I mean the starting point of UI is at I mean the aeroporto militare grosso. This is one place in Tuscany. So if you wanted to visit the 20 places, accordingly the agent will provide the number of places in this sequence. These are the 20 places which is recommended by the reinforcement learning agents. The next objective is the tourist social media data analysis, classification, and topic modeling. Here we are utilizing the social media data having the two parts. One is the tourism hospitality and tourism healthcare. This research have been conducted during the COVID time, peak time of the COVID, basically when the every people were inside the home. They were not allowed to go outside. So the what kind of sentiments they were sharing from their home, So what kind of hospitalities the government has provided and how they have been treated as for the healthcare wise. So the data has been collected with the different terms like COVID hospitality, COVID hotel, tourism hospitality, tourism hotels. Then for the healthcare, tourism healthcare, and tourism hospital. These are the few terms, and we will able to collect them these number of tweets from the both um, domain. Then the both data has been gone through the cleaning, then converting to the numerical to the I mean the text to the numerical using the WADR. Then LDA based technique been applied for topic modeling, the sentimental analysis along with the deep learning based classification. This is a data cleaning process, converting lowercase, then removal of user mentioned, then removal of punctuation also. These are the few things which need to be taken care before building the sentiment analysis model. Topic modeling process, basically it is one kind of text mining process where we are dealing with the high dense of data. So how this data can be summarized in the lower dimensions space. So that's how the topic modeling is working here. So the techniques what we used here is the LDA based topic modeling technique. LDA is one of the top popular used technique which is help us to feature the higher dimension space to the lower dimension space. There are the three steps. First step is to determine the separability between the classes. Second step is to we must compute the distance between each and every classes, class means and samples. Third step is finally the lower dimension space will be created that increases the variation across classes while minimizing the variation within the classes. So this is one of the visualization uh, LDFI, one of the Python libraries which has been used to visualize the data. So if we are able to see this cluster number 4, so the kind of terms, these are the top 30 relevant terms like tourism, video, travel, hospitality. This is given by, and how many times this term is coming. The tourism is coming around more than 200 times. Then hospitality is coming around more than 150 times. So these are the terms, how many times it is happening, it is visualizing here. The same things for the healthcare, where if we are observing that the cluster number 1, same in the hospital having the second frequency, since the tourism is coming in the first, because these are the keywords what I use to retrieve the data from the Twitter platform. So that's how it is showing here. Then the to build the sentiment analysis based classifier, we use the LSTM models. So 85% data have been used to build the deep learning model with the different epoch size, and 15% has been used to utilize for the evaluations. Then based on that, we will able to see that for each and every epoch size, the with the 15 epoch size, the accuracy what we achieved is 99.6. Then test accuracy was around 80.9%, and validation is also same 80.9 scores. Then for the tourism healthcare also here, the highest accuracy whatever is achieved. But here for the healthcare, we are able to get good accuracy for the epoch size of 10. So this is sometimes the number of epochs based on the data varies, and that's how the LSTM has given the performance for the classification. Now the next part with the same objective is that knowledge based topic retrieval for the recommendation and tourism promotion. Here the basic purpose of this is to develop automated system which will perform three subtasks like predicting star rating from the review, a feedback model, and a knowledge based recommender system. So this is one of the diagram which has been used here, that we are utilizing the ELB data set, and then getting through different pre-processing technique, then having the vectorizations to vectorize the textual data into the vector format. Then same data is being used for predicting the star rating, and based on the matrix whatever been prepared, a vector matrix whatever is prepared, that has been sent to apply the different kind of techniques to retrieve the topic, like the LDM based topic retrieval, then NMF non-matrix factorization, non-negative matrix factorization techniques which is being used here, then k-means clustering. These are the models which has been used for the topic modeling. Then for the recommended system, whatever score is coming through NMF, that model score is being used using the silence and valence calculations for the feedback and for recommending the um, restaurants. So ELF dataset, which is founded in 2004, having the 2.4 million review, one of the widely used database for research purpose. So they have completely given open source, and that's how the in this research study this dataset has been utilized. This is the same quite the previous study what we did, that the data has to be get through proper cleaning process. So one of the reviews which was given by users, it has been pre-processes, it has after pre-processing, the number of words have been removed, and we are able to see the less number of tokens here. Then for after the experimental works, we utilize the into the three parts. One is the service time, second is the stop, third is the food. So K means clustering, LDA and NMF. These are the three algorithms which has been used to retrieve the topic. So what are the terms which are widely being used while going with the service time, then for the stop? So we are able to say service time is based like chicken, food, love. These are the few terms what are widely being used as a review. Then for the staff also. So this is a result for using three optimal topics. But NMF having some extra features, we will able to get retry the topic with the more high dimensions. So for the top five topic, if we'll see, they are this has been retrieved through NMF techniques. Then feedback model has been prepared by using salience and variance scores, and feedback, how does it, how many restaurants are there in the in the USA, then in the particular area, even in the particular states. So from top level to bottom level, each and every feedback models have been prepared by utilizing the salience and balance score. So we will able to see here that service time, service time for the restaurants review in the USA, it has been observed that variance score is giving in the negative, but silence score is positive. So that's how this graph shows that. But let's say if you'll see the Japanese restaurants feedback, even for that also service time is negative, and for Musahi, even in the single restaurants also service time is negative, but other part is quite positive. And this is the observe and expected review based on the hypothesis whatever been used in the data set. So we are able to see here the restaurants review in the USA, how the service time is I mean the observed number of reviews is around 19,000, then expected is 38 38,000 around, I no 3,86,000. So these are the some hypotheses which has been prepared by collecting the samples from the data, because data set is very big, so we need to make it a bit smaller to provide the proper feedback models. This is the same in the different dimensions, same expected positive review and observed positive reviews. And then we will the predicting star rating part, utilize the different models like random forest, decision tree, logistic regressions, k nearest neighbors, and support vector machine. We were able to see that random forest has given the highest accuracy like 87.9%. But knowledge based recommendations, the matrix what we prepared using an NMF technique that has been used utilized using the KNN approach, and then along with that there is a one more matrix called CSR matrix, which is helping us to provide the top recommended places. So this is a top 10 matrix which is depicted here. I mean the top 10 restaurants for the Dimitri. If the user inputs is Dimitri, based on that we will able to see these many models. So based on this research, we will able to see that that tourists will able to find some unseen restaurants which is not yet explored, and they will able to find even less priced and more optimal hotels. That's how the Then next objective is the cluster based knowledge graph and entity relationship representation. And here the data having the different phases. I started with the data collections, then data pre-processing, then data has gone through vectorization, then sentiment labeling, and data has, based on the sentiments, it has been clustered, so that we will able to analyze that in which cluster the positive reviews are there and negative reviews. And then uh, before selecting the cluster, we tries to find the optimal number of cluster, that how many number of cluster needed to cluster the data into different clusters. And based on that, we it tries to extract the entity and relationship to represent the knowledge graph represents. This is a sample data set which has been collected from the tweeters. So before uh, after, I mean, the pre-processing of the data has been converted to the vectors. So here using the word to vec models, this is quite popular model, which is basically combination of CBOW and skip grams. And CBOW, basically it takes the large number of text and minimizes the smaller text. Then the less same skipgram model operates the opposite directions, attempting to predict the background for the given terms. Then sentiment labeling have been done using the Bader scores, which is between the -1 to +1. Then clustering, for the clustering, K-means clustering have been used, which is one of the unsupervised classifications technique. And this is a formula which is used to select the best number of clusters. So silhouette score, basically it tells that how many number of clusters need to be selected for the optimal way. So we found that here around five could be the optimal number of clusters, because after that slope is keep on decreasing order. So that's how here we selected cluster number 5. Then cluster wise entity relationship extraction, how does it works? There is a, let's say there is a one tweet, why sees July visitor arrivals plummet from a year ago at tourism economic. It has been divided into the two entities. One is the July visitor arrivals and year tourism economic. That's how here. So the same data has been uh, you know tagged with the different patterns like root, then prepositions and adjective, all this thing. So we are able to see here that siege is verb here, and July is a propositions, then visitor is the noun. That's how the automatically this is tagged by the spacey library, which is pre-trained models. Then um, during the cluster based entity relationship extractions, we found that the relationship around each relationship is having the more than 5,000 thousand frequency, and B is having more than 700 something. So these are the top 5 or 6 relations which has been extracted through spacing. Then the how the data has been distributed for the 5 cluster. Cluster 1 is containing around 9,000 tweets, cluster 2 containing 24,000, and so on. And then based on that, we are able to tag each and every entities. As I said, the species a pre-trained model which helps us a lot to utilize it properly to train to the particular level. So we are able to see that Egypt, Saudi Arabia, these are the locations which is being tagged with the GPE tag. Okay, then Mia is the person which is tagged, and Kenya is the location. So that's how, based on these entity and relationship, we are able to draw this knowledge graph. And we can see here in the degree level that few of the words like tourism economic, even economic pataya, few of the words which are being used and inheriting some relationship between each other. So basically knowledge graph help us to find those terms and relationship between those two terms to get some meaningful information. That's how it works. But there is a few other libraries, like uh, Neo4j, that gives more you know proper visualizations, accurate visualizations, where we will able to see the each and every information properly. So last objective is tourist facial expression prediction and applications. This is the one of the deep hybrid approaches model. So basically we are utilizing the image data set, and data has gone through the pre-processing techniques. It has divided into the two parts: testing, validations. I mean three parts: testing, validation, and training. Then model has been developed. Building the for the building the model, there is a three models which is being utilized here: LSTM, CNN, and transfer learning. And there this model is being tested with the different kind of evaluation matrices for the testing. The data set along with the FER data set from the Kaggle, we tries to collect the data from the different sources like Google Google Images and Bing Images, and that has been merged. And to checking the duplicacy of the data, we use one of the pre-trained model that is called CAPI model. CAPI model basically helps us if the same image is coming two or three times, it will remove other duplicate images and retain only single images. And we are resizing this image to the 48 by 48 dimensions. That's how the this data set is being used. So how the CNN is working here: CNN having the input layer and having different kind of uh, uh, you know layers like con 2D layers, because we are converting to 2D two dimensional, I mean the 42 by 48 by 48. So it has get through these layers. And then we have the first hidden layers which has the parameter of 5112, 3 by 3. And then again second layers with the same number of parameter, third layers. And then after that, each and every layer having the batch normalization, layer normalization, max pooling, dropout layer. Sometimes if the few layers need to be removed, we can use the dropout layer. It can be increased from 25 to for 50% also, based on the how much size the data we are using. And then flatten layer, and after the flatten layer we are going with the output layer. This is the same explanation of the CNN. Then along with the CNN, there is a transfer learning which help us to utilize the pre-trained models. And the below like resonate 50, VGGNet, inception, exception, and exception resonate. These are the model which has been used to experiment this study. And we after the transfer learning, we use the LSTM model also, which is basically help us to deal with the temporal kind of data set. And models which the LSTM model contain the 128 multiply 64 unit. Each LSTM layer is followed by batch normalizations and layer normalization along with the dropout layer, which has the probability of 0.5. Then this is basically the proposed deep hybrid learning model. So input will be given to the inception resonate v3. And then CNN having the four layers, four time the it has been being used. Then a time distributed layer which helps us to pass the uh, uh, pass the output of CNN to the LSTM layer. Then LSTM also will go through different process like batch normalization, layer normalization, and dropout layer. And based on that, we are using flatten layer and then dense layer to get the output. So this model giving the below results, I mean the angry having the 83% precisions, then 0.79% recall, and F1 score is 81%. And for the happy 80%, 84 for recall, and this is that. And if we are able to see the hybrid models, the training accuracy is around 95%, validation accuracy is 81.42%. We use the number of epoch size around 100, and able to see the precisions 80%, 80 for the happy level, and for the angry 83%. So this is we are able to see that the deep hybrid learning model is doing better than the individual models. So based on that, uh, we are able to see that deep hybrid learning models can be performed better than the individual models, and this can be extended to the next level also. And this work has been published to the one of the models, I mean the journals, that is called Image and Vision Computing. So concluding the work, of course the forecasting model is very necessary nowadays to get the trends of arrivals, and this will help us to pre-plan the services which can be improved for the tourist. And future works can be extended by using clustering based techniques, where we can group the most arrival countries, even mid arrival countries and low arrival countries. Based on that, we will able to build the model accordingly. Then for the tourist recommended system, still lot of works need to be done. And uh, we utilize here the review location rating from the various region, which is given by the users. And more works need to be extended by building the more accurate recommended system model. Then for the classification, still uh, data needed more from the different sources like travel blog, and from the trusted places like the booking.com and tripadvisors. The social media data is more hypothetical. It cannot be relied as much. So to building the proper classifier, we need more uh, uh, accurate data, which is provided by the agencies. And yeah, then cluster based for the knowledge graph, we have utilized the networks library for visualizing the data, but neo4j and other more visualized and library algorithms or packages need to be developed, where the informations can be depicted properly. Then in the tourist facial expressions, the model is performing well, but still few more improvement need to be done in the future extensions. Like these models has to be deployed to the embedded platform like Raspberry Pi, Jetson, and the real time platforms. These are the references. And thank you so much.